Hey everyone, my name is Jordan Rose. I'm a manager in the CNC machining division here at Protocase. The purpose of this webinar is to give you an overview of our machining capabilities and how you can use our Spaceport America Cup manufacturing sponsorship to get parts you need for your rocket. First, a quick overview of what we'll be talking about today. I'll briefly explain the sponsorship we're providing, a little backstory about Protocase, and then we'll dive into machining itself. We'll go over all the materials we stock, some tips for creating manufacturable designs, and then I'll point you to some resources. So, right off the hop, your sponsorship. Each team registered in the Spaceport America Cup gets $1,000 of free manufacturing services. Any orders you place that exceed the $1,000 sponsorship, you'll get a 50% discount on. This manufacturing sponsorship can be used for machine parts, sheet metal parts, or any other manufacturing service we offer. But I would bet that you'll mostly be keen to get machine parts or sheet metal parts. We love doing these sponsorships because it gives you university students the true experience of what you'll be doing when you get out into the working world. You are all extremely busy juggling school commitments and assignments while also designing and building your rockets for SAC. By working with us, you'll be able to focus on everything else while we take care of professionally manufacturing your custom-made parts so you can build the rocket you're envisioning. Protocase was started by two engineers in the early 2000s. They were struggling to source custom metal boxes for their work. They'd waste a bunch of time trying to make an off-the-shelf box fit exactly what they needed, including trying to manually cut the boxes themselves. Using mass custom manufacturing, meaning we break down each unique customer order into repetitive work and custom instructions or parameters for what specifically needs to be made. Our turnaround times are fast, and we never, ever make our customers order a minimum quantity. Essentially, we help engineers, scientists, and innovators meet their project deadlines by making their custom parts quickly. And that's exactly what we're here to do for you. Now, on to our capabilities. We may have started with custom sheet metal enclosures way back in the early 2000s, but we have expanded into different areas to serve our customers in engineering and innovation. We have a full-service CNC machining division that includes milling and turning. We also have our sheet metal fabrication side, which Cody explains in the sheet metal webinar. We also offer 3D printing. Another station we have here at Protocase, which may be important for your design, will only add one additional day of manufacturing lead time, is chem film conversion. It will make your part corrosion resistant, more durable, conductive. It can be applied to any aluminum part that is within the size constraints shown on the screen. Very much sought after by a lot of the students we've had in a number of our competitions over the years. So maybe something that interests you. So to start, what is CNC machining? CNC machining stands for Computer Numerical Controlled Machining. Machining is a subtractive manufacturing process. Essentially, a CNC machine can be thought of as a big robot that controls a cutting tool to remove material from a piece of stock material. So you start with a large piece of material and you remove it away to get your final part. At Protocase, we have 3 manufacturing stations for CNC machining. The first, as you can see on the slide, is our 5-axis and 3-axis mills. The other 2 are our CNC rotors and our CNC lathes. You guys do not have to know too much about these apart from the types of parts that they can manufacture. So a CNC mill would manufacture something like this. So this is a somewhat smaller part. The geometry is a little bit complex. You have some posts and some little L shapes. A rotor, on the other hand, would manufacture something more like this, which is a flatter part. We have limitations on how thick of a piece we can cut on the rotor, so this would be much more suited to the rotor. And lathes, as many of you would be familiar with, are specialized in cutting cylindrical parts, so ones like this. In addition to that, we also have a number of other stations that can be used on CNC machine parts, and those are mostly for secondary processes and finishing options. So those are the stations that we would use to make your part. We stock a number of different materials for CNC machining. We stock aluminum, bar stock and round stock, stainless steels, plastics, copper, cold rolled steel. All of that can be seen on the slide. In addition, if you're looking for specifics on what we stock, you can hit up our website The main thing is that a stock material is going to give you a lower lead time than a non-stock material would. However, if your design requires a non-stock piece of material be ordered, Protocase will handle all that. That is one of the benefits of one-stop shop manufacturing. So now that we've covered the basics of CNC machining and what materials we have available, I want to talk a little bit about the types of features that can be manufactured on a CNC mill. So if you take a look at the slide, essentially a mill is used for contouring parts. You can see the contouring feature there, pocketing parts, putting grooves or slots into parts, can do tapped holes, drilled holes, profiles on parts. All sorts of different types of geometries can be made on a mill. So now that you guys know the basics of CNC machining here at Protocase, I just wanted to talk a little bit about the constraints that are involved around CNC machining. All this information that we're going to go through over the next few slides will be available on our website. However, it is good to review it in this way so you get a little visual as to how it all works. So let's start with one of the most important things, inside corner radius. Inside corner radius is a limitation that we have based on the geometry of the tool that we use to manufacture a part. As you can see in the video, you can see 4 corners of the part. There's lots of corners on the inside, but the 4 main corners are formed entirely by the cylindrical shape of the tool. This means that the radius of the corners is determined solely by the radius of the tool. Since we have a finite amount of stock tooling here at Protocase, that limits the size of the corner radii that we can have on our parts at certain depths. That's described both on this chart as well as on our website. So you can see an end mill diameter of 1/2 inch can do a minimum corner radius of 0.25 inches to a maximum cutting depth of 4.25 inches. Another limitation that we have is tooling reach. There are 2 examples in this slide of features that would not be able to be accessed because of limitations in tool reach. So the example on the left shows a pocket on the inside face of the part, but there's actually no way for a tool to reach in and create that geometry as the side opposite of it is solid. The example on the right, a little bit different, but there are holes on the bottom of that part. So a tool wouldn't necessarily be long enough to reach down and form that hole on that bottom face of the part. So there are limitations to both where certain features can be placed and the size of features with tool reach and corner radius. If you take one thing from this presentation, it's that when designing your parts, you should reference our tables and information on the website in order to ensure that we limit back and forth during the quoting process with features that might not be machinable or need to be tweaked slightly to match our tooling. The other important consideration you'll need to make when designing your parts are tolerances. You need to make sure everything fits together. The standard machining tolerance we will hold at Protocase is ±0.005 of an inch. This is for both lathe, rotor, and milled parts. If you require a tighter tolerance, we may be able to do it. There may be some concessions made for lead time or price. However, we can accommodate tighter tolerances in some designs. So when it's time to submit your design for quote, please submit any of the file formats that are shown on the screen here. We accept STEP, Parasolid, SolidWorks, all sorts of different file formats. So choose the one that is most suitable to you. So now that you understand what our manufacturing capabilities are, how do you maximize your budget? Essentially 2 things. 1, review the size of stock materials we have on our website and make sure you design parts that fit within those stock sizes. If you don't, we'll have to order non-stock material at an additional cost and lead time. Additionally, CNC machining is a more expensive manufacturing process, so if you can design a part for sheet metal manufacturing, definitely do that first to maximize your budget. As I mentioned before, to make things run smoothly, you really need to make sure that you're reviewing the design constraints on our website, as well as understanding our tolerancing. And that way we eliminate that back and forth that we have with you at the quoting stage and make sure we get you exactly what you need in as fast of a time as possible. Make sure you're project managing and that you give yourself enough time to both get your design created, submitted to us, gone through our approval stage, and then into manufacturing, and then get it back to you and actually do some testing so that it will work. Transit times vary internationally, so make sure you take that into account too. So what do you do next? So first, you can watch our other webinars on the ordering process and the sheet metal manufacturing process. Additionally, go on our website, watch our YouTube page for all of our tech tips. That will help influence how you're designing your part. And then review what type of stock materials we have on our website. Once you're ready with your designs, email info@Protocase to get connected to your account manager and get the order started. Thank you all for taking the time to watch this webinar on CNC machining at Protocase. Be sure to sign up for our live Q&A at the link below. Thanks. Bye-bye.